Welcome to the final episode of Season 1 of Zeroing In, the Science Podcast. I am Naman Jain, and hosting this episode with me today is Prakhar Agarwal, who is an aerospace engineer and has been working in ISRO as a scientist for the last 9 years. He is also a graduate from the very first batch of the Indian Institute of Space Science and Technology and is currently pursuing his advanced masters at ISAE Super in Toulouse, France. We're extremely elated to have here with us in conversation an internationally renowned veteran from the field of space sciences, a distinguished Indian scientist, Dr. B.N. Suresh. Dr. Suresh has been associated with the Indian Space Research Organization, or ISRO, for a little more than 50 years now, a Padma Bhushan and Padma Shri awardee. For his riveting contributions to the country's scientific and technological growth, he has closely seen and shaped the Indian space program almost right from its very beginning. Presently serving as an honorary distinguished professor at the ISRO headquarters in Bangalore, Dr. Suresh was formerly the director of the Vikram Sarabhai Space Centre in Trivandrum, formerly the president of the Indian National Academy of Engineering (INAE) in Delhi, and former member of the Space Commission of India. His role in defining the activities for advanced technology development and their planning for space transportation in India has been very significant. He joins the distinguished group of individuals who, by their achievements in the engineering of systems, have contributed uniquely to crucial technological developments in the country and enhancement of the society at large. This podcast session is especially interesting as partaking in this discussion with us, we also have some of the India's brightest and curious young students from secondary schools joining us from various corners of the country to ask their questions to Dr. Suresh directly. The schools participating with us here today are Kendriya Vidyalaya No. 1 from Palakkad in Kerala, St. Xavier's Senior Secondary School, Jaipur from Rajasthan, Nagarjuna Talent School from Hyderabad, Sherwood Public School from Sikandrabad, Heritage Valley the Indian School from Shadnagar, Anjuman-e-Islam Alana English High School from Mumbai, VMJ School from Madurai, Somalwar High School and Junior College from Nagpur, and Kendriya Vidyalaya from Barakpur, West Bengal. We extend a warm welcome to all the teachers and students and look forward to their curious questions along the discussion. And of course, again, we would like to extend a very heartiest welcome to Dr. B.N. Suresh. Welcome, sir.
It's my pleasure. Let me thank all of you for organizing beautiful session. And always I am excited to meet and spend my time with the youngsters. Very nice to see all fairly good number of youngsters, I think, across the country.
Sir, we are really glad and honored to have you here with us. So we'd like to start with the most fascinating and broad idea at the outset. And this is something that you've always addressed in the beginning of your sessions or any public talks as well. Why is rocket science so complex? Would you like to briefly talk about the excitement of the whole undertaking before we delve into the details?
Now that you asked a very interesting question, which is always my favorite because, rocket science essentially signifies a task which is very difficult to accomplish. That's how the word rocket science has come. When we talk about space, whether it's a launch vehicle or rocket which puts the satellite into the orbit, or the satellite once launched, it has to stay in orbit for almost 10 to 15 years and carry on the task assigned to that. Now, all these things can happen only if you are able to sort of visualize how it works and how to make it work without any time. You see, many of the systems that we see are it may get into problem, and so much so what we do is we try to correct it and take it forward. For example, you take an automobile and some problem comes. What you do is just take it aside, get it rectified, and then move on. But in space systems, you can't do that because any one failure of any kind, whether it is simple or complex, it will end up with the catastrophic, what we call mission failure, costing a few hundreds of crores for the exchequer. So that's why it becomes very, very complex, and how we are able to do that, visualizing all possible scenario, all possible failure conditions and make it robust. What you need to do is that you have to build systems with zero defect or even perfection, what we call. That is extremely important. That's why I keep telling all the time, that if you master the rocket science, essentially you are able to perfect in whatever you are doing. I think you will do a good job, and always you will come out with colors in whatever task that you are going to undertake. Okay.
Indeed, that's a really beautiful bit. I believe there is one thing that is very prominent when you usually address this question as well, and I would just like to point that out again so that we can probably elaborate into that a little bit. And that is, what is it like making a rocket from scratch? Would you like to elaborate on that a little bit?
Yeah, I will not get into the details. I think it's a very interesting question. I think any probing mind should get fascinated by the way the rocket works. After all, it takes about 20, 22 minutes. The moment we give the countdown and call T0, the way it majestically takes off, and within 17 to 20 minutes, it places the spacecraft in the precise orbit several hundreds of kilometers away. And what is required to build it, basically, when you talk about rocketry or launch vehicle, it consists of all branches of science and engineering. I think what all our young friends learn in their school, college, and engineering, all of them you need to apply, because there is what is called propulsion system, which gives the energy. Just like you have the engine which provides the power to the car to drive. Then, of course, you have the structures which houses the entire energy package into that. Then you have the control guidance. Basically, it's the brain which really guides it autonomously to take it to the final slot. Then you have the mechanisms which separates the spent stages are thrown into the sea. Then you have several other components coming into the system. If you really look at one vehicle, it will contain as many as 400 to 500 electronic packages or avionic packages we call. And if you really look at the wires that is in a vehicle, top to bottom, back, forth, if you really measure the length, it will run into 100 kilometers, something like 200, 300 kilometers of wire will be running up and down. So all these things require very meticulous planning, very meticulous design. More than that, I think, as I mentioned to you already, once you have various disciplines, it becomes multidisciplinary. Not only multidisciplinary, it also becomes multidimensional. So you can see the complexity of the system that we are building. That means you have really number of scientists, engineers mastered in different areas. Like I said earlier, in the propulsion, in the control, in the structures, in the mechanism, in the avionics, so on and so forth. And all of them have to work with synergy. It's always, I always keep telling, it's like big symphony orchestra. So why I'm saying that is, even if one person plays a wrong note in that big symphony orchestra, the whole music goes off. Same thing happens in rocketry. If anyone does any one simple error or mistake, whole mission will be out. That's why I keep telling that it requires to build one standard vehicle which can put satellite into the orbit. Maybe something like 2,000 to 2,500 scientists, engineers, they have to work together along with the other support staff. And in my opinion, if you are building a new vehicle, it takes between 8 to 10 years for you to build. That is the kind quantum of work that is involved in building the rocketry. And one can go on and on, but I think that's suffice to say that this is the complexity with which we build. That's why we always keep telling the most complex system that one can think of is building the rocket, assembling it, integrating, and making it work.
I think this is a really great answer, even from the perspective of a child, a student who's learning things right now in school as well. We've heard your answer to this question in the most complex of details when you've been taking our courses in college as well, and it is really different to see you answer it extremely simply and with the same fascination. I think the next question that I would again like to ask at the onset, which is again pretty broad, is about your long journey with the Indian Space Program. From the days when you were a young engineer and working on to this day, your clearance is a key for authorizing missions and launches right now. So, how has your experience evolved for you in that perspective?
I was in a way fortunate enough for having joined somewhere in the middle of 1969. And incidentally, I want to tell you, I think for our young friends, I joined just a week after the historic feat of Neil Armstrong and Buzz Aldrin landed on the moon. In fact, that excited me. By then, I had joined, but then, since then, I've been participating in almost all launches. So far, we have had launch of 76 launches from Sriharikota, our own, and the one that we had on 7th November this month was the 76th. And I think we have positioned as many as 104 satellite of our own Indian satellite. And I also want to tell you, today we have something like 50 satellites which are active in the sky. We call them space assets serving the country in several ways. So every launch is an excitement. Every launch is a new launch because we never know that by saying that I have launched seven launches, eighth one I can go with confidence. No, it's not that. Every launch is a new launch, and we don't know what would happen. And that's one of the reasons we have a methodology developed over a period. How do we check? For example, when you go for a medical checkup, they call all medical checkup they call, and on the same line sort of feel the pulse of the various systems that are available in the rocket, and then we monitor them on a continuous basis. During the countdown also we monitor, and satisfying all these conditions are met with, we can say that system is healthy and we can allow them to go ahead, and that's how we press the button when the launch takes place. But after that, everything is assessed properly. It will go on working. Everything works autonomous. There is no intervention of any kind. Once you press the button till it put the satellite into the orbit. So that's where the complexity we need to address and then look into that. But then for us, when we sit there and then go through the launch phase, during the countdown, of course, we are very calm because any problem coming, we can stop, try to attend and correct it. But once the vehicle takes off, nothing is in our hands, and every minute, I said about 17 to 20 minutes, every minute will be something like, for us, will be equivalent to 1 year. That is the kind of palpitations that we have sitting in the control center. And nothing else we can do excepting praying to our own favorite gods. And till the satellite is injected, I think we are all very tense. And you would have seen that the moment satellite is injected, we get the data in the control center, and all of them jump with jubilation. That is the excitement and that is the experience that we have. But then that experience comes because of the hard work put in by thousands and thousands of scientists and engineers for a national cause.
Indeed, that's immensely fascinating to hear, sir. So, at this bit, before we start off with the detailed discussion, can you briefly explain all the areas that ISRO works in and the tasks that it majorly undertakes at present? Because right now we have a very small view of all that ISRO ventures into.
Yeah, if you really talk about ISRO, we cannot start without recalling the founding father of the Indian space program, that is Vikram Sarabhai, a visionary. And somewhere in the early 60s, he visualized a country like, poor country like India, those days, in the 60s, we have advanced so much in the last 5 or 6 decades. But then to see that we have to have a space program, and while addressing the UN, he made one simple statement that we must be second to none in the applications of advanced technologies for the benefit of. Having said that, he always had that in mind. We must utilize the space because once you put the satellite, it goes into the vantage point in the space, and we can utilize it for the various other applications on ground which will benefit the common man. So, in other words, the first and fundamental thing in any space program is the application. When I say applications, what are the applications? It could be remote, it could be communication, it could be navigation, it could be disaster management. All these different functionalities will come into the picture. And when I talk about remote sensing, then using the vantage point of space and putting proper instrumentation, I can sort of utilize the data, those are so collected for various other applications. I think I'm sure that all youngsters might have heard. For example, you can use it for agriculture, you can use it for forestry, you can use it for fishery, you can use it for rural development, urban development, so on and so forth, many other areas. I mean, there is no end to that. Similarly, once you put the communication satellite, you have shrunk the whole globe into a small village. And today, it is very well connected. The broadcasting, I think we have as many as something like a 60, 70 million connections are taken through the direct to home by 7 different operators, private and public. And then similarly, the disaster management, there were days where we had difficulty to manage disaster, cyclone or even heavy rain, so on and so forth. So first place is to reach out to the common man. That is the application. That is the important one ingredient. Having said that, second is what? Second becomes having the payloads. Payloads means, you put instrumentation. That is fundamental. Once you put instruments on board and then keep it in the sky, those instruments are able to make the measurements that is necessary to carry on these applications that I have mentioned earlier. So you put the payload into the orbit. What you do, you need to build a house for that. That's what is called spacecraft. Spacecraft essentially keeps the payload inside and provides the house like our own house provides all amenities needed for us to stay and then on with the life. The payload also is managed like that. Once you have the spacecraft, then that provides all needed amenities for the payload to operate, then transmit the data and then data. Now, third element, what Sarabhai visualized was we should have an end-to-end program, not only application, the build the spacecraft, but also you should sort of launch it. Many countries, if you really look at it, very few countries have ventured into launching the satellite into spacecraft because that becomes one thing is very complex and the cost is high. Facilities that are needed are very complex, but still he visualized, and that's why the third component is the launch vehicle. So if you ask me frankly, there are 3 important ingredients I want to repeat once again. One is the application, which reaches out to the all 1.37 billion of the population. Then in order to generate that data, what is required by each one of them, you need to have the payload. Payload basically is instrumentation, and you house the payload in spacecraft. Then once you have the spacecraft, you also launch them by using our own launch vehicle. This support, of course, we have several other programs, and all these activities are very well sort of organized and put it in different centers all over India, and that's how we carry on the task to meet the requirement. And if you ask me frankly, today, 5 decades are over, what Sarabhai has visualized, that what ISRO should do for the country, I think I can humbly accept that we have reasonably done that job, and today we have reached out to each and every segment of the society and trying to help them in several ways.
Indeed, that's completely undeniable, and it's extremely fascinating and informative to hear these facets of ISRO that we do not know about after having even come this far while working with it. So, there's this bit that I would like to ask you about. As you were seeing all this happening in the 80s and 90s, the Indian space program actually developing, we were the sixth country in the world to be able to become a spacefaring nation. And even till now, there is only 11 countries in that list. So, how have you seen the development of ISRO and in general, even personally through anecdotes or so, uh, that ISRO was able to sustain through its program for so long, given that we were in a developing state and the world was always questioning at some point about how such a country would develop a state of the art program as we lead now?
Yeah, this is a very interesting question. But then, a country like India, if you analyze how we are able to sustain, how still we are able to sort of remain one of the competitive organization, because I think the way in which I will get back to Sarabhai's vision, who visualized that we have to align all our development towards the national development. I think we have not departed from that particular goal even today. Whatever we do, the majority of the tasks that we do, our launches, our missions, we always sort of align to meet the country's demand, be it remote, be communication. That's one of the reasons, although the uh, GPS is there and then GLONASS is there, all of them are support us, but then we know that for sure at the time of difficulties, we can't depend on global positioning system. Today, it's available in all our mobile, in smartwatches, everywhere it is there. But under the difficult circumstances, they may just stop it. That's why we came out with our own innovative way of doing uh, seven satellites in navigation, and today it is put into service. What we call as the navigator. So what is driving us is really meeting the needs of the country, and today its application is increasing tremendously almost everywhere. The automobile sector, railway sector, the fishermen using it, and I think also the receivers are coming in a big way. So that in maybe another 5 years, you will find in Indian mobiles, wherever it comes, it will have the GPS as well as Navic. So we can depend on our own. So what I'm trying to drive at is that demand keeps on increasing, and the arena of our involvement also increases. See, after Honorable Prime Minister Modi took over as Prime Minister, he was very familiar with the space activities while he was in Gujarat, and realizing the importance of that. The first thing he did after he took over within a very short period, organized a big meeting at Delhi and calling as many as 75 different departments, and he himself came and sort of inaugurated, spent considerable time, and secretaries were there, and examined how the space data that we are generating can be utilized. Number one, how much more data that you need the space to generate, and what kind of planning they have to do down the line, 5 years, 10 years, 15 years, various department. And in fact, that activity not only seeded, today it's being monitored by cabinet secretary with all departments. As many as 158 projects are running even today, and our hands are full, honestly speaking. So it's not that just trying to launch a satellite, trying to put something in the sky. I think it's basically trying to meet the requirements of the country in any of the areas I talked earlier. So that being so, transponder, I mentioned that today the demand in the country of such a big country is more than 500 transponders are needed, whereas we have only around 270, 280. Still, that gap has to be filled. And of course, also the high speed internet requirements have come in a big way to remote places and all that. All said and done, even today, the bandwidth requirement is not to the mark that we would expect as a country. So there are many, many things that we need to do. So I can tell you that we have a very long agenda to meet the requirement. While we have that, we can't be left behind in some of the advanced areas like interplanetary mission. That's where Dr. Kasturangan visualized. We must develop a capability, and Chandrayaan 1 was defined, Chandrayaan 2. But you look at it, it is not the main agenda. In fact, we do it in addition to this important requirement. Same thing, it took almost 10 years when I was the director of VSSC. We started the work on human space mission. It's now more than 10 years, but then it was approved just 2 years back, and we are working on that. Why? Because, how the things will turn out from now to another 5 years, 10 years, nobody can visualize the way in which the technologies are advancing. We have to be in the league. I think we have to develop that habit and then keep moving. So there is a very good combination of meeting the requirements of the nation, then developing advanced technology to meet the future demands, and also trying to generate a blueprint which is needed for the country as well as from the global scenario, so that we have a dream of becoming one of the advanced nations very soon. I think we have to work towards that too. So these are all, we have to look in totality and take a comprehensive look actually.
Yeah, that actually prints a broad picture of how space program is so relevant and so much needed in a country like ours, where the space program is contributing to the applications and development of the country. You mentioned an interesting point, sir, that we are venturing into interplanetary exploration and that we even have human space flight. And I remember that you initiated that space capsule recovery experiment, which was successfully conducted in 2007. Perhaps you can throw some light on how it was initiated, how was the work like on it, and whatever else you would like to share about it.
It was a very interesting topic because the space recovery experiment, if you really look at it, it is the spacecraft module which is in the orbit, and you are trying to sort of reduce the velocity and bring it back and recover. There was a very, very strong debate going on the way in which we have organized ourselves, whether VSSC should do it, because being re-entry, it's equivalent to rocketry, VSSC should do it. But being a spacecraft in the orbit for several days, deorbiting, the URSC do it. What happened that somewhere in 2004 or 2005, the then director of VSSC, Dr. Srinivasan, was there. He's one of the again pioneers in rocket technology, and he appointed me as the chairman of the committee. And when I really looked at it, it looked to me that this project cannot be done by one or the other. This has to become ISRO's program. That with that idea, I walked into director's URSC room. At that time, Dr. P.S. Goyal was the director. Then I sat with him and convinced him there is no point in saying, you do it, I do it. This is not the way you're going to work. I think it has to be done in combination with all ISRO centers. For example, propulsion has to come from LPSC. The SHAR has to worry about the completely recovery operations. Satellite operations you have to do. And finally, we were able to come to some common agreement. And Madhavan Nair was the chairman at that time. We went and told him, and then it is a big story. We all sat together, spent one full day, and then the baseline is whoever has made good advance in any particular technology, they will do the job, not X or Y or something. When a simple example, the navigation guidance control, they had to work like a single unit. But ISU was mastering navigation, they will do it. Then guidance, always VSSC master, they will do it. Control, the spacecraft control, more like a URSC will do it. We distributed ourselves, and then they put me to review the completely integrated technical aspects of that. And the difficult portion here, if you really look at it, apart from all other things, because it enters and then comes back, it is subjected to the very, very high temperatures, when it comes through the atmosphere. So you need to have some kind of a thermal protection system so that when it's subjected to that 2000 degrees Celsius plus outside, inside should be less than 67 degrees Celsius, so that all the instrumentation, everything remains all right. And also you guide it properly and come to the point where you want to reach. Then also I told you the recovery operations, you have to have the coast guards, you have to have the ship, all that. There are a host of technologies. Then we worked almost like a single team. I think the first project, if I'm correct, where the VSSC, URSC, Sriharikota, ISTRAC, all of them worked like a single team. And it went very well. Suffice to say that it succeeded. But what I would like to add, one thing here is, country did not realize the importance of this particular mission, honestly. But, I was representing India in UN deliberations at Vienna. And in the very first, that happens somewhere in the month of February, when I went and then made the statement, I myself was surprised. Every country congratulated India for accomplishing this recovery so precisely. We were supposed to come in an ellipse of 50 by 70. We were right on the dot when we recovered. That was the kind of precise with which it was done. It was a very, very satisfying project. And the globe realized how difficult it is to come through for the first time, first attempt. And I want to add that those whomsoever have heard this, if you happen to go to Trivandrum, there is a museum available. Particular piece is kept there. I think this is possibly the only piece which has come from heaven is available in ISRO.
That's extremely fascinating and inspiring to hear. It very clearly strikes out in your conversations that ISRO has been able to find a real balance between healthy competition and teamwork. And this is what brings about successes. We've also seen in terms of teamwork that ISRO collaborates with international bodies. And there have been collaborations in the past, and there must be some collaborations in the current scenario as well. So, how do you see that ISRO's collaborations with other agencies will go forward in future?
As far as the international collaboration is concerned, when Sarabhai started way back, Tumba Equatorial Rocket Launch Station, that's where the first seeds of international collaboration seeded, because he had such a big clout with various agencies. Like, he got the rockets from Russia, the France, England, US, all advanced countries. You were able to get them, so that we were able to get the tracking, we were able to get the launcher, we were able to sort of assemble many things, because by looking at it. So that started, I think, the particularly with Russia, our long-standing partner continued. I think all of you know that we depended on Aryabhata, Bhaskara, their own launchers, and our own cryogenic engine GSLV-3. Even today, and even Human Space Mission, they are helping us in several ways. So also with US, I think we have joined hands, and of course the France. You know that our the Earth storable liquid engine, we got trained there, and then what we call as the Vikas engine is the really the help provided by them. And similarly, we had initially the gyros accelerometer. We got it from several agencies across the globe. So we strongly believe that as we move forward and forward in the space arena, because it is expensive, it's important for us to join hands and enhance the international cooperation wherever possible. Sometimes it's possible because it depends on the geographical partnership that we may have. Sometimes friendly, sometimes not so friendly. All these kinds of things will be there. So one has to factor all this and then move it forward. But for example, when the International Space Station was done, in fact, we were not even invited. Maybe that's one of the reasons Kalam used to tell all the time, strength respects strength. Have the similar strength what we have today. But if they really visualize that they must have a similar program, I'm sure they will first invite India for two, three things. One is we have the capability, we are economically competent, and our youngsters are second to none. And so I think all these things will factor. And then today, that's why people are looking more and more towards India to join hands. And we also should do it in a selective manner wherever it is advantageous to us. We can't simply on the bandwagon and get in for the sake of it, but we have to always look at the pros and cons and the kind of relations we have with each of the countries and move forward.
I think that paints a really interesting picture, and the whole view is quite judicial in the sense of taking the program sustainably forward. I think we can have a question from one of the students at this point. We have the first question coming from Pragadishwar. Pragadishwar, can you please ask your question?
Good morning, sir. My name is Pragadishwar. I am from BMJ School, Madurai. My question is, what attracted you towards aerospace and avionics engineering after graduation from mechanical engineering?
I always believe that when you go and join somewhere, whatever task given to you, I think you should carry on. As scientist and engineer, what we learn in our school and colleges is really try to learn the task that is given to you. Whatever is needed to be learned, you can learn. Basically, that ability we have to develop. So happened that when I joined way back in 1969 and reported for the task, I was given the development of a control system which I had not studied, which I had not seen anywhere. I had not touched a computer. I didn't know anything about simulation, because these are all the important things that one should have to develop a control system, build it, and you should have electronics to control that. Then you have to have simulation to simulate that. But then it was little surprising to me, and as well as disheartening, because what I have studied I am not able to use. But then my boss at that time, he simply made one statement: "Look, Suresh, you are all engineers. You are sort of taught how to do things new and take it as a challenge and do in the process something new." I think that particular statement made me to really take on and then carry on the task. It took some time, but in a matter of something like 2 to 3 months, able to learn whatever is required of you to get started. And as you started moving further, you will get tremendous opportunity to learn many things, not only by reading the books, by interacting with your peers, by looking the similar tasks elsewhere. There are many ways of learning. And it's a good question that you have asked, because many times I have seen our young friends that they get fascinated by doing something in their final year or fourth year, and they feel that, oh, I am specialized in this, I am not getting that job. No, I think you must be prepared to take any job that is given to you. That is the job of the scientists and engineers.
Sure, sir. Thank you, Pragadeshwar, for your question. We have the next question coming from Muhammad Ayan Khan from Mumbai.
My name is Mohammad Ayan Khan and I am from Anjuman Islam Allana English High School. So my question is, why is so much money invested in space exploration?
Yeah, it's another good question. Anybody who listens to talk on space, that is the question always one can expect. It's like a leaked question, I would put it that way. Because, you are not realizing that the money that we spend and the money that we are able to give to the country. There was one study initiated by the one Professor Shankar of Madras School of Economics in Chennai, and he did it about 8 or 10 years back. And then, that money that we are spending and then the amenities that we are providing to the country, if you really translate into real economics, he has concluded saying that for every paisa spent, I think the space has given something like 3 to 4 paisa back to the country, 3 to 4 times. So you may be surprised how it happens. There are very many ways of doing that. For example, today, the communication, the way in which we are getting connected across the country and across the globe, how we are able to do that. We have as many as 230 to 40 transponders, and demand is something like 500 transponders. All the broadcasting that you need for the various requirements in the country is linked by that. The financial sector, all banks are linked through our own spacecraft. When you look at the ATMs today, all ATMs are linked through our own satellite connections. Similarly, the share market is linked with that. So you can see that our spread in several areas have gone in a bigger way. That disaster management which is coming. I think all of you know that eastern coast, what happens is every year the number of cyclones they come, because geographically it is located like that. It starts somewhere in the Bengal, and then anywhere it can strike, from Tamil Nadu to Pradesh to Orissa, West Bengal, then Bangladesh, Myanmar, anywhere it can happen. But then the way in which we have sort of come out with the technology development today, in the about 8 or 10 years back, huge cyclone came and hit the Orissa coast. But the technology that we developed, also the understanding we have with the state government and other machineries, so happened that not a single life was lost. Same thing about 20 years back, when we had not advanced technologies like that. More than 10,000 people in the same Orissa coast, they had lost lives, not only human lives, the animal lives, many things. There are very many this kind of tangible and intangible benefit accrued. Only thing is, this is not so clearly visible. That's one of the reasons, I mentioned earlier, Sarabhai said that we have to use the advanced technologies. No doubt they are expensive, but then we have to use it for the benefit of mankind. This is the benefit that we are giving in return.
This was the first of the 2 parts for this season's final episode of Zeroing in conversation with Dr. B.N. Suresh. It has been supported by Alumni Association of IIST. Zeroing in aims at bridging the pronounced gap between the school students and academic mentors, enthusiasts of science, technology, and research, and the graduate school academia and scientists through the length and breadth of Indian subcontinent and even further. Tune in to the second part of this episode, where we continue this conversation with Dr. Suresh on the inception, journey, and success story of the Indian Space Research Organization. the ideas that shaped it, the first plans and implementations of human space program by India, and the invaluable reflections of the process from a first perspective.